Okay, let's do 3.2, solving systems of equations. Now today we are going to review a little bit about the graphing, but we're mostly going to be focused on the substitution method and the elimination method. But again, you can do it one of three ways: graphing, substitution, or elimination. Alright, so the first one, graphing both equations. And in this instance, you have to have both of them in y equals, and that's supposed to be 4. So in this case, they are already, so you can go ahead and start graphing them. But if they're not, you just solve it for y. Alright, so the first example says 3x minus 4. So we know that's going to be a parent graph of a linear equation of y equals x. That has been shifted down 4. 1, 2, 3, 4. And then it has a stretch of 3 or a stretch of 3. 1, 2, 3. 1, 2, 3. Okay. There's my first line. Alright, and the second line says y is equal to negative x plus 2. That tells us that it's going to be shifted up 2 and a reflection because of that negative. So it's going to be shifted up 2, and the slope is going to be going down 1 and over 2. Down 1 over 2. Down 1 over 2. Down 1 over 1. Down 1 over 1. Down 1 over 1. Alright, so I'm going to graph my line. It's a negative line, so make sure that you're doing this correctly. This blue line is a negative slope, this red one is a positive. Alright, so the intersection then would be this intersection right here. This would be one solution. And that solution would be that ordered pair. And it looks that it's flat goes that it intersects right here at looks like 1, 1. Looks like 1, 1. My back's going to be a little bit bigger. Alright, so the next way we're going to go is by substitution. Substitution, you're going to solve one of the equations for either x or y. It doesn't matter, whichever one's easiest. And you're going to plug into the other equation. You're going to solve that for that variable. Okay, so once you plug it in, you'll be down to just one variable. Then you take that variable and you plug it back into your original equation and you solve for the other variable. The two answers you will get will be your x and y ordered pair. So, for example, this one says x is equal to 2y plus 6. And the next one says 3x minus 2y equals 10. Well, I noticed that one of these is already solved for a variable. So I can just take this one because it's saying that x is this. If x is that, I can go and plug it in right here on the other equation because x is that. So I'm going to do that. I'm going to take 3 and I'm going to put a big placeholder minus 2y equals 10. Okay? Then I take this and plug it in right there. So this is going to be 2y plus 6. And then you go ahead and distribute and solve. So this is going to be 6y plus 3 times 6 is 18 minus 2y equals 10. Right, put your y's together. That's going to make 4y plus 18 equals 10. And then you keep on solving. You subtract 18, you subtract 18, and then you end up with 4y equals negative 8. Y will then be negative 2. Alright, so that's going to be my y coordinate. I take that y coordinate and I'm going to plug it into my original equation. So I'm going to take this and I'm going to put it right there, okay, for my x value. So I'm going to write it up here. So I'm going to put it up above here. So x is going to be equal to 2 times, and y is now negative 2 plus 6. So x is equal to 2 times negative 2 is negative 4. Negative 4 plus 6 is 2. So my ordered pair for this answer is going to be x is 2, y is negative 2. That is my answer for my solution. Okay? So you simply just take one, solve it for a variable, either x or y. You plug it into the other equation. That eliminates one of your variables, and then you solve for that letter. Plug it back into the original, and then you get your other coordinate. Let's practice on these. All right. Elimination is so named because you're eliminating a variable. Now, you must line up the equation vertically in standard form. Oh my goodness, what standard form? That's ax plus by equals c. Yes, it's back. It doesn't go away, but you have to set it up and line it up that way. Okay, that way you can vertically see what you can get rid of. You must have the same coefficients, and you must have one of them to be positive and the other negative in order to cancel them. I personally like elimination because I think it's really fast, but some people can do the other methods easier, whichever way. It doesn't matter. Whenever you're given a formative assessment or something like that, you're allowed to figure out whichever way you want to go. All right, so I'm going to do this problem right here in our example vertically, and I'm always thinking of this as adding, okay? So I'm going to look at my variables. Can I eliminate my a's right now? No, because yes, they do have a coefficient of 1, but one's not positive and one's not negative. One is positive, but they're not opposite. So I'll look at my next variable. I'm looking at my b's. I have a negative b and a plus b. Can I eliminate that one? Well, I have a negative and a positive. That's check one. And they're both a coefficient of 1. So yes, I can eliminate my b's. And that's which way I'm going to go. So when I do have this, I have a negative b plus a positive b. They go away in just plain old 0. So then you go and add these. 1a and 1a make 2a. Equals 14 plus a negative 4 makes 10. And then you go ahead and finish solving for a. A is going to be 5. Okay? So then you plug it back in so you can find your other letter. So I'm going to go back up here to the top. I just prefer using the top. Unless you mess around with it and change things, just go back to the top. So a is going to be 5 minus b equals 14. All I did was take it and plug it in right here. Okay? You can plug it into either one of them right now because we didn't change anything in the problem. Down the road in a few minutes, we're going to be changing some stuff, and you'll see why I just put it into one that's simplified. All right, so back over here we have 5 minus b, so I'm going to subtract 5 from both sides. And this is going to be negative b equals 14 minus 5 is 9. And then we can't have a negative variable, so b ends up being negative 9. So our solution to this is going to be 5, negative 9. Now, notice we have different variables other than x and y. Okay, they usually put them in ABC order. So if it was A, B, A would be like your x, B would be like your y. If you have order, letters that were like M, N, M would be your x, and N would be your y. Okay, so just put them in ABC order. Okay, there's the solution. All right, so the next one, sometimes you have to force the elimination using multiplication. Now, when you do this and go plugging back in, I always recommend that you plug it into the one you didn't mess around with. Didn't change it all. And you'll see why. All right, so I'm looking at my A's. Right now, I do have a positive 2 and a negative 6, okay? But the coefficients are not the same. I have a 2 and a 6. I'm looking at my B's, and I have the same situation. I have a negative and a positive, but the coefficients are not 1, and they're not the same. So I can do one of two things. I could, decide I want to eliminate the A's. Either choice is fine. If you want to do A's, you'll do it a certain way. If you want to do the B's, you'll do it another way. It doesn't matter. So I'm looking at my A's, and I'm thinking if I multiply this A right here, by 3, I would make then a positive 6, and these would cancel. So I'm going to put a 3 over here. Now when you do that, you have to multiply every single thing by what you put over here, 3. Everything, okay? So I'm going to make a little arrow, so you'll see my work. This is going to be 3 times the 2a, which is going to be 6a. And then 3 times negative 3b, which is going to be negative 9b. And then 3 times the negative 4, which is going to be negative 12. So that's now my new problem. And we can do that because the multiplication of the same thing, we have a property that says we can do this. Multiplication says that we can multiply everything and not change the problem. Okay, so same thing, just not simplify. All right, so now, because I have that, I can just rewrite this one without changing it. Sometimes when you're doing these, you have to change them both. In this situation, I was able to just change one. So I'm going to go over here and put minus 6a plus 9b equals negative 15. Okay? Now, again, this is now adding. Okay, so 6 minus 6 is going to be gone. But look what else happened over here. We have 9 and they both cancel too. So then this is just 0 over here. Okay, the 0 equal, when you add these together, it's negative 12 and negative 15, that's a negative 27. So 0 equal negative 27. No, we do not. So this is a no solution. Sometimes that'll happen. Sometimes you'll get 1 and it'll end up being like 5 equals 5. That would be your infinitely many solution. Okay, so all your variables completely cancel out, you have 0 over here. And you add up your numbers. So if it's not a true statement, it is a no solution. Okay? All right. Again, you're going to practice these, and we'll do some more in class. Again, sometimes you may have to change both of the equations. Just remember, you have to have the same coefficient, and you have to have one positive and one negative in order to eliminate. See you in class.